issue. I'll be plugging in the computer. And I have my computer up and running right now, which, yeah, so I have here, there's a microphone here if you want to use it. There's a microphone on the podium which you can turn on by pressing, so it is active.
Okay.
I have a remote here if you like to use one of these with a dongle, so you just plug it in and you can use it right away, and it has a laser pointer on it too.
Okay. I should have one.
Yeah, if you don't have it, I have it here for any of my presenters to use at any time. So, what kind of computer do you have? A Mac? Okay, cool. So I have one of these Thunderbolt hookups.
Okay.
So will that work for you?
Yep.
Okay, good.
So I just try it.
Yeah, let's give it a shot. Is there any sound that you need to do? I remember at the Triangle Rooming meetup, you wanted to do a video and I think it had sound.
Yeah.
And that was a big hiccup. So I thought about that.
Yeah, and it's the same. I actually have the exact same Thompson.
Okay.
I've seen it already.
Mm-hmm.
But you know, I could just put the microphone on there.
So and we also, I think your computer might have an HDMI.
Yeah, that's right.
So this is a straight HDMI hookup. So you can go HDMI directly and sound will carry through that
Okay.
cable.
I didn't even know that.
So I think that'll be. This is a really good venue. So.
When I updated, I've never heard of anyone else having this problem. When I updated the OS, it has since kept every presentation I've done since then open.
Oh my lord, really?
Yeah.
No
So,
way.
And I've talked to my IT staff and they can't figure it out.
Oh
and
my
I keep
goodness.
waiting for some great upgrade or, fix. But I think I need to put the others here.
Maybe one of us can take a look at it after the, maybe we can get, Corey is pretty good with this stuff too, so maybe myself or Corey can take a look at it afterwards. And there might be something in the settings or something. Oh, I used to work for Microsoft.
Oh, really?
Oh, yeah.
All right, so here's, finally got it open.
Yes. Okay, it's gonna, what's the display? Oh, it's mirroring right now, or it's doing dual display right now, isn't it? Here we go. It looks great.
Oh, okay. Okay.
Do you want to give the video a shot? Yeah. Vision's looking good.
Now if they click export, it would pop up.
Good. Yes. Oh, that was like one of my biggest goals. Because I wanted that part of your presentation to go off successfully.
That's
so.
good memory on your part.
Oh yeah, I always, I take this stuff very seriously.
Hopefully it'll
Yes.
maybe open up 72
Shouldn't do anything crazy.
slides for everybody.
So all of us are used to crazy presenter things. I had a friend of mine, I think at a conference once when there was a presenter and he was plugging in and having issues and the guy was like, oh gosh, he's not prepared. I looked over at him and I was like, you never given a talk, have you? And he was like, well, I've given presentations in my office, and I was like, yeah, but you've never gone to a remote location that you've never been to before and given a talk and had to use the equipment.
Yeah.
I was like, it is very regular to have issues.
Yes, it is.
We all just kind of hang out and.
Let me make sure. Okay. Yeah.
Okay, good.
My computer knows mine. Probably knows. I think it's the same as yours. All right. I think I saw ladies room. Oh.
Yeah.
Across the wedding.
It's, yeah, right down that way, directly to your right.
Okay. Thank you.
No problem.
I never asked you how long.
Probably an hour or an hour 30. Depends on how much time you take. I'll give you as much time as you need.
Yeah, an hour.
Yeah. Joe's the one that's under time restrictions. No, I'll give you as much time as you need because I know that you're talking about like stuff in your area. So, yeah.
so much better.
Tomorrow you get the whole thing. This weekend.
No, I don't have anything saved.
If you want to go amongst your business,
Yeah, I'm sitting.
All right.
Thanks.
we
Appreciate
can
it.
talk about that.
Nice off here. Text break. The whole and a half of this is the best post. Oh, really? You know that heard a lot of people talking about it. Yeah, it's like a new seat. What are your languages?
Well, these days, root Rails, JavaScript, PHP, root Java, all the random stuff.
But I never done Python.
But no, the data science stuff is going on master's. I had access. For the Ruby classes, how many hours did your weekend spend?
It was a long weekend now.
The basic version.
The basic version takes 2 years.
I ended up doing like high index space.
You want something next to you?
I thought it would be clean today.
Yeah, okay, good. Yeah, I was gonna scoop us.
But I was in the lab all weekend.
You were?
Yeah, I was the only one.
Oh.
I think I spent like 20 hours.
Okay, yeah, that feels a lot like
Your Ryan was like,
But I mean, I was doing like learning how to high index for fractional computer and that. We did the strict word thing too. We were doing the people thing, man.
right.
It was fun.
Long story short, it was fun. We can beat you up. Maybe not.
Ryan. Project.
We do have sponsors. It's okay, you cannot do that. Policy in the rooms, it's great. It's a film everyone. Oh, I did forget about
No, it's drawing now.
Well, it's like probably
Will you be here
So I'm just going to grab everyone's attention here, and I'm going to introduce our two speakers. But before I do that, I kind of wanted to introduce the Stack Meetup to everybody and explain what it is, because a lot of people always try to have a tendency to ask me the question, Brandon, you do this Stack Meetup thing, but it's not like a Ruby meetup, it's not a JavaScript meetup or a Python meetup or a DevOps meetup. I don't understand what it is, and people always just think, oh, general technology, that can cover a bunch of stuff. So Stack is, our mission is directed right now towards, yes, general technology, anyone that is in technology, but we're in the process of defining what it means to be a full stack developer. That term gets thrown around by a lot of people, and I get a lot of people scoff at me when I say it, and they're like, full stack, that's ridiculous. The term is dumb. It's a businessing term that people use. But I decided to use it because I felt like it really appropriately describes something that I feel like is a trend that's developing in the technical community at large, specifically in the web development community for me, being a web developer. I've worked as a web developer for about maybe like 8 or 7 years now. And I remember early in my career, someone told me that a web developer has to have a really general level of knowledge on a very wide breadth of things. Stuff like HTTP protocols, web browsers, how to write good APIs, how to do Sass and CSS and Ruby and Rails and JavaScript and Node.js and application servers and Apache, Nginx, how to configure them, how to stand up servers, how to provision them properly, how to scale them, how to descale them, so on and so forth. I mean, just the list goes on. But I've kind of taken that meaning to a different level. It's not just a wide breadth of technical skills that I feel like a developer should have. There's also a wide breadth of interpersonal skills. Things like writing blog posts, being able to get your thought across effectively, being able to resolve conflicts with each other in between in between coworkers at a company. I mean, we're all developers, and I feel like it's a pretty general thing that all developers are really opinionated, and they're strongly opinionated, and our blood runs really hot when it comes to talking about something that we're passionate at, which is typically coding and technical stuff, which is what we work in all the time. So I mean, like things like pair programming, that's a really volatile situation to get into. And I mean, there's tools and techniques that you can use to make it an effective thing and how to do it properly. And also, you need to know as a developer when it is proper to use it, stuff like that. And then also knowing things like rustling. I mean, that's a deep dive technical concept of something that you might want to learn or may be effective for you in your job. But I can see myself having to learn or use Rust at some point. So that's kind of what I'm going towards. That's my personal vision of what it means to be a full stack developer. And I feel like going into 2015, we're going to slowly start to really solidify and define what that is. So in 2015, there's a few things that we're going to be focusing on as a meetup. The first of which is going to be high quality quarterly meetups. I'm not really here to start Stack to just be like, oh, it's a meetup and kind of like an informal thing, and we all get together and we talk about a really specific topic and we do it every single month. This is not what Stack is. Stack is going to be very high quality. We do 2 speakers. We're going to do it every single quarter. We're going to have food provided at these quarterly meetups. But also we're going to break this out a little bit further, and we're going to have kind of like monthly events, things like just smaller stuff like lightning talks, maybe like a panel of speakers or a panel of people up here, experienced technical people that individuals can field questions to. If any of y'all, I know this feels like a really formal setting and it's like in a theater or anything, but I mean, if any of y'all have any suggestions or anything that you would like to see Stack do or topics that you would like to see covered, just come to me and tell me about it, and I'll see what myself and my core organizers team can do to make that happen for you guys. Another big thing, though, that I'm trying to do is just bring together just people from a really diverse technical background. I want to see a meetup or a room full of people who do DevOps and also who do maybe some project management and UX and design people, and also developers, front-end developers, back-end developers, JavaScript developers, Ruby developers, Python developers. We all have like different skill sets and knowledge that I feel like that we can kind of like mix together in the triangle. The triangle slowly has, like over the years, I've seen that the technical community has really seriously grown, especially with the sudden birth of like the Iron Yard and Tech Talent South and like HQ Raleigh and stuff like that. There's a lot of like new people into the area, and there's a lot of like developers that have been around for years and longer than me even. And I mean, it's just it's really been like my goal to kind of form a meetup where we can bring everyone together instead of separating out, the Ruby developers go over here, okay, the JavaScript developers have your meetup over here, and we're not going to like communicate with each other. But cool stuff is talked about those meetups, and I feel like people, there should be a bridge between those two things. So I like to think of Stack as like an alliance between all of these different communities and bringing everyone together. And the final thing is a conference that we're going to be having in June. We do have a set date. We do have a set location. Yes, this is happening. Okay, this is not. I've had a lot of people come together and do just a serious amount of work to make this an effective thing. And I'm going to go into a lot more detail about what this means for all of y'all, what it means for the technical community in the Triangle at large, and what it specifically means for Durham. So we'll talk more about that at the end. But right now, I'm just going to go ahead and go straight to our presentations. First presenter is going to be Joe Jackson. He's going to talk about rustling. And then our second presenter is going to be, come on up and hook your thing up, man. The second presenter is going to be Laurie Williams. She's spoken a few times at meetups that I've had in the past. Her talk is excellent on pair programming, so I'm definitely looking forward to both of these. So without any further ado, Joe. Do you want this?
No, I'm going to do it with my
Well,
I've already practiced that way.
If I'll go with you up here, just in case you want.
If I want to point at the screen, I'll just jump really high. Cool. Hey everybody. So I'm going to be talking about Rust, and specifically Rust Lang. They have a Lang on there, so you can Google it, because if you Google Rust, you'll get a game or any number of oxidation states of iron. So if you do search Rust Lang, you'll find Rust docs. So the first thing I'm going to do is introduce myself, and then I'm going to have. So I might go back to the laptop if this like fancy HTML5 thing doesn't work. But my name is Joe Jackson. I am as it says up there, I'm a web and mobile developer at Smashing Boxes. And I would consider myself a full stack developer, but not in that like some like deep knowledge of all aspects, but just in like a willingness and an interest in being able to sort of deal in the full stack. And today we're actually going to be talking about kind of the lowest level of the stack that you can get. So some of you have a lot more experience with this stuff than me, so feel free to call out and correct me. And some of you haven't seen this stuff before, so I tried to make it really approachable. If you have any questions though, while I'm doing it, please do stop me. And let me see. I'll give you background after I do this. All right, cool. So on your seats, it's actually posted on the front of the seats. So you're probably going to have to get up at some point. There's a number, and I was hoping to number 1 all the way up to the top. But what I want you to do, wait before you stand up. Cool. Is I think I have 1 full row, so that's awesome. I want you to stand up, you're going to look at your number, and you're going to remember your number. And at some point, I may address you by that number. I know you have names, but I'll be asking you for your names. So the other thing you're going to do is you are going to just introduce yourself to people on either side of you. If you know them, introduce yourself again, I guess. I don't know. Have a quick chat. So go ahead and do that, and I'll get back with you guys in a second. We're just going to do a quick exercise, and here's the thing. I'm gonna ask number 1, what's your name? To give me the name of the person who is the number. I don't even know what that number is. I should know. Is that 11? Is everybody on this row 11? 13. 13. Okay. To ask me the name of the number 13 without yelling or without getting up, right? So you can figure that out for yourselves. But number 1, I would like the name of the person in number 13. No.
I'm not going to lose.
This is why we use computers for this stuff. we already know number one's in. I'll just leave it at that. We're going to do more with that later. Just keep that in mind. I like how my computer's going back.
That's awesome.
I need to turn off. Does anybody quickly know how to turn off the screen? Happy. So I'm going to run out of battery. Let me switch to the one that actually works here because it's necessary, because it's a little easier for me to work. All right. Cool. So I'll talk to you later about like, what all that meant, but it's actually fun to just get started with something. Let's see. Is it not going to sync up? Nope. So there's the next video. And I'll just walk out. All right. So, Rust-Lang, a general-purpose multi-paradigm compiled language. It's designed to be safe, concurrent, practical language supporting pure functional, concurrent actor, imperative procedural, and object-oriented styles. So this is actually the definition. I had to go to Wikipedia for that because I was really hoping that like the Rust-Lang was like a website that's like created by people in their basement who made this stuff really well, and like it would be like completely impossible to understand. But what they say, and actually this is gonna hold true for like most of their docs in general, is actually really good. Rust is a systems programming language. It runs blazingly fast, prevents almost all crashes. On the site, it has a little asterisk. I'll tell you that in just a second. And eliminates data erases. And this is a big, big claim if anybody knows anything about low-level systems programming. It may even seem impossible, but it is possible-ish, sort of. So the prevents almost all crashes. The asterisk is Rust is an alpha. It can do anything, including crash your entire computer. So safe. So what I'm going to do here is I'm going to talk a lot about like why you should care, right? Like this is like you're like blazingly fast, cool. I guess JavaScript's pretty fast. Prevents almost all crashes. You know, if you just rescue exception, then you don't have any crashes. and eliminates data erase as well. There's like fancy languages like Elixir and stuff like that that can do concurrent programming. So why is this important? Oh, I was hoping it would work.
There you go.
Oh, woo. All right.
It's a little laggy.
All right. So this is actually just some Rust code. I realized when I was putting this presentation together that I had gotten like 3/4 of the way through the presentation without showing you any Rust code. Because what Rust does is actually not about its syntax. This may look like a lot of stuff, but some of it should be familiar. If not, don't worry about it. But I'm going to use not the laser pointer, but the pointer to point out some sort of basic things about Rust that shouldn't really surprise you if you know other programming languages. So there's a function keyword, right? And that just defines a block of code. There are, in fact, blocks, like lexical blocks, like you might be used to in other languages, JavaScript, CSS, and Ruby. And the only weird thing that you might see here, well, the first weird thing you might see here is this let. Basically, that means var. But the difference between that and var, like a regular variable, is that let, by default, only lets you assign once. So we'll talk later about what that means. But you see right there, it's assigning a string value that is sort of incomprehensible, plus, multiply, minus, divide. But that's just a regular old string. And you'll see that the accumulator below it, it says let me. And that tells the compiler that it's mutable. So that's like a regular variable, but you have to do it explicitly. By default, everything's right once. I'll gloss over a lot of this stuff, but for-in should be familiar. That's just a loop. You don't have to worry about iterators. Rust takes care of that for you. And then match token, that's a bit of a special case, but you can think of it like a case statement or a series of if-else's. Checking that token against each of these blocks. One thing to note here, just because I won't get to it later, is this underscore. Rust compiler will make you catch every case. It can tell, except for some very, very rare exceptions, what every possible case of that value is. It'll make you catch it. Usually you'll do it with an underscore to catch just everything it can. Everything you don't explicitly match. There's a macro here at the bottom. That bang means macro. If you don't know what that means, that's fine. And this just prints a string out. The result of this is just the result of adding 1 to 0, adding 1 to 0, multiplying something, I don't know. Multiplying by 2 and then dividing by 2. So that's just a little bit of Rust code. And the whole point is not to this is right off the main website, rustlang.org. You can actually run this in the browser. There's a couple of places where you can do that. And you can play around with all these values and variables. And the basic idea here is to show you that there's nothing scary. It's nothing weird. It should be very familiar to anybody who's done any programming. All right. I'm going to go back, but that's okay. Come on. Okay. So when I was trying to decide what to tell you about Rust, it's a big language. There's a lot to worry about. And there's one feature of Rust that I think makes Rust a killer app, essentially. And that makes it more powerful than a lot of the other new languages that you're seeing. And that is memory safety. And so that may mean absolutely nothing to you. It meant absolutely nothing to me a few months ago. We're going to have to go down the rabbit hole to figure it out. I'm going to try and sort of, you saw the turtles. And I was going to say that this slides.com site has this weird vertical slide feature that I think is kind of pointless because you just see one slide after another. But when you say something like, let's go down the rabbit hole, come on. You can make it go down. All right. So the whole world of computing, as it exists now, or of programming, and most of computing is built on C. So in our world that we live in, we have this lag has been a fun glitch. We have things like Java, like a programming language that a lot of people use nowadays. We have JavaScript, and this is clearly not inclusive. We have Ruby. Underneath that, we have the virtual machines that these things run on. These are built in C. And if you don't know what C is yet, we'll talk about that. You have compilers, you have just everything, all your tools, even your browsers are built in C and C++. So your operating system, the whole stack. So C all the way down, well, almost all the way down. We'll talk about that in a second too. So what's wrong with C? I would like to say that there's nothing wrong with C as a language, but C as a platform is fundamentally unsafe. So Mozilla, so a guy in Mozilla started writing the Rust language in about 2008. And Mozilla picked it up a few years later and has been sponsoring it ever since. And the reason that Mozilla is picking up a systems level language like this when Mozilla is all about web is a couple of reasons. First of all, their browser engine is built in C and C++. And it's giant, and there's pieces of it from when it was Netscape in 1997. And basically, every year people get together and try and hack browsers. And every year more security holes are found, and they're all sort of due to memory management in a very specific way. So the security of C can't be determined by looking at the code once it's big enough, and it is an opt-in feature. There are like some compilers that'll flag things, and again, like if I'm saying anything that's wrong, please do raise your hand because I'm not a C hacker, but security is opt-in, right? And so sometimes the easiest way, sometimes even the fastest way to do things is a fundamentally unsafe way to do things. So what makes C unsafe? We're going to go further down the rabbit hole, and we're going to talk about pointers. Maybe the dogs. So nearly all fatal errors in C, nearly all crashes, nearly all sort of memory leaks, and you hear about some of these coming out in the news every once in a while where somebody finds a security vulnerability somewhere in the operating system or bash or something. Most of these are pointer errors. So, does anybody know what this will do? There's got to be at least one person who knows what this will do. Yeah, what's that? Capital.
It's gonna capitalize hello. In hello.
Interesting. You might be right.
You just had to pause, even if you got myself.
Yeah. So that's a pointer, just so you guys know, and we'll talk more about what that is. That's also a pointer. All right. So according to Wikipedia, anyway, that's going to segfault, but people who know more about C might tell me differently.
You're right.
Yeah, that was right. So what that was doing was writing to read-only memory. We'll talk a bit about that in a second. And same with mutation faults or signal that are sent from the operating system. These are not like your normal errors. It's not an error in general where you can catch it and do something different and save yourself. Seg faults, though they are like sort of the least of the problems as far as security goes, are fatal. Like crash, your process ends and you don't get a stack trace, so that's always fun. My notes are on here.
Joe?
Yeah.
Are you including buffer overflows in the pointer problems, or is that a different category of problems for you?
That's sort of a different category, but that is a real thing. Yeah, they're not really a pointer problem, but they are it's something that will cause a segmentation fault. They might be a pointer problem. So anyway, what are pointers? Why are they such a problem? Well, let's go down the rabbit hole. The rabbit hole starts to get pretty weird here.
Actually, one of the buffer overflow tricks is when you override a buffer, you override pointers as well, and then when someone executes those pointers, you're executing what they wanted you to.
There you go. So we are on a level below C. We're talking about assembly and raw machine code. Assembly is pretty much just pretty raw machine code. I'll show you what it looks like in a second. And in this place, what you know about programming breaks down. You don't have abstractions like variables. You don't have control structures like if or for or any of that. And you don't have data types. Like you don't have strings. You don't have, well, that's a little bit of a lie. And you don't have the difference between an integer and a float, right? So, but they're friendly dragons. Does anybody know what dragon this is? Peach dragon. Yeah, I thought it was Puff for a while too. You can tell by the apple that it's a peach dragon. They won't burn you. They won't travel from the past to rule the world. They won't steal all your gold and sit on it for centuries. But they might crash your computer. This is what Hello World looks like in machine code. Except for, of course, on this side, this is hexadecimal. And I don't expect you to be able to understand that. Could, right? Like they knew all the machine instructions, they knew memory locations, and they would input this stuff and take the output, and it would mean something. So that's like Ada Lovelace and some other of those early computer people. But that's not quite right. It's actually kind of like this, without the spaces, actually, right? So, or without any of the formatting. We can talk more about what it is in particular, but each one of these is a word, and each one of these lines is dealt with by the processor. But we'll just sort of, we won't talk about that. Cool. I think I said things are different here. I just wanted to say that programs are made to be read by people. Computers don't care. Computers want zeros and ones. There's a nice website that I'm probably not going to get time to show you. But here is a bunch of instructions for a CPU. Don't worry about what they do, but this is great. Everything is built from these. This is a dumbed down 8-bit. So these are kind of the things you can do, right? And the other thing is memory addresses, and that's kind of why I had you guys remember your number. Like there's addresses, there's CPU registers, there's code segments, which is where the code that you load lives, stack segments and other stuff in like system memory, and processor will treat these differently depending on what processor it is, but essentially it's all just addresses. Cool. So I'm going to actually bring this up. So this is a assembler that you can run in your browser. These are RAM addresses filling up with hexadecimal values. It doesn't really matter. And then they're outputting onto memory locations that you can see down here. So we can stop that.
You're right, self-modify.
I tried. The code lives somewhere that is not accessible. I was going to show you and I wasn't able to because this nice little box, this memory, and there's some things you can't do. So what this thing right here, and what that is just a special for a pointer in memory. So what's happening like 1, 2, 255, 4. This holds another location in memory, and that sort of moves around and stuff like that. But the value actually comes from wherever E is, and that'll be somewhere. I don't know. Doesn't really matter. But I just sort of want to show you that. I was going to show you it crashing, but it doesn't crash. So cool. So let's play some more. So from that row, what I want to do is I need to sort of rush. Yeah, so I want to show a couple of these. So your numbers are pointers, and what I mean by that is that so you're in number 1. So unfortunately, I'm going to have to do these demos super fast. I miscalculated how much time I have. Is that I'm going to give you a number, and you're going to tell me the name of the person in that slot. So this is a really rough estimation. So I'm going to initialize you as a pointer, which means I'm going to give you the number of somebody else. So just for simplicity's sake, we're going to say 2, right? And so when I ask for the value back, so what's the value of 2?
Andrew.
Andrew, you already knew that. Okay. So the other thing I'm going to do is I'm going to potentially initialize you as a pointer, but I'm not going to tell you what you point to. Which should make intuitive sense, right? If I say you point at something, your value might be 0, your value might be like garbage data right now, but I don't tell you what you point at. What are you going to tell me? Yeah, he's going to tell me segfault. Yeah, that's what he's going to say. Actually, the operating system's going to tell me segfault, but that's fine. Boom. So writing to read-only memory. This is all C examples, by the way. Some of them very contrived. So I'm going to actually do another. So what's your name? Adolf. Okay. So I'm going to give you a pointer, and I'm going to have you point to 2. So can you tell me the name of the person in seat 2? Vivian. All right. Vivian, I'm going to free you, which means you can go anywhere, but just for now, just go the next seat over. Just sit one seat over. Thank you for putting up with me. So now, this is a little bit not quite right, but assume that that she has been retrieved by the operating system. She's no longer available. She's one seat over, but that's fine. So now, if I ask you to give me the value of the person in seat 2, same fault. Yeah. The operating system told me same fault.
Joe.
Yeah.
In the real world, her moving doesn't necessarily. Yeah, I was going to say it's a copy that's made from there to there, and her ghost still lives in seat 2.
It is true, except if the memory is reclaimed by free to the operating system. So there's like a little bit of semantics.
Yeah,
Yes.
unless it's reused by somebody else, it still retains its old value.
Yes, exactly. That's why I was like, this is a little not quite right. Okay. So we're going to access an array out of bounds.
Joe, you have a tracker up here.
I'm
That's passionate.
Well, I'm just going to add on to what he said. That in some ways it's worse. I mean, because it doesn't necessarily get cleared up. It's not like you did something wrong and boom, it fails. You can get garbage data, and it can go ahead and give you a value, and you get an answer, and then after a while things start going wrong. And okay, why did this go wrong? And eventually it crashes. And trying to trace back to where that problem was could be really hard to find.
That's actually a really, really good point. And I'm going to make that kind of right now. So I'm actually going to make these two an array of length 2 of people names, right? So can you give me your name?
Jess.
Daniel.
All right. So what I'm going to do is get the array at value or at index 2. And can you just go sit there? No, one more. You can move back in just a second. All right. So what I want you to do is do you have a pet?
Yeah.
Chinchilla, what's his name? Her name?
Chili.
Chili? Okay. So I'm going to index array at 0 here, and that's Jess. So when I ask her, hey, array at 0.
Jess.
Hey, array at 1.
Daniel.
Hey, and you're going to say the chinchilla's name. Hey, array at 2. Chili. Well, that's weird. That's not a person's name. So actually what's going on here, I need to hurry up because I'm but is that arrays in C are indexed using pointers. And it just and you just add 1 or add 3 or whatever. So those two things, this and that, are equivalent. Where's the boom? So that's what somebody else was saying up there, is that this won't necessarily segfault. It can, if the memory where he is, so if you want to move back to your seat, is freed by the operating system, operating system will segfault, right? It'll blow up. If it's not, if the name of his chinchilla is in the next memory spot, then you'll think you have a person's name, and you'll go do some operation on it, and it'll blow up because it's a chinchilla's name. And that's what I'm talking about. This is all very real world. Shared memory and concurrency, I don't think we have time to go over this. I was going to have people like run around and like try and take over people's seats, but you can see what would happen. I need an hour, guys. So basically, in C, dealing with memory and concurrency is what like that. All right. So strategy 0 is garbage collection. Let's see if I have anything. So what is garbage collection? Garbage collection is your language, which is almost every language that you probably know, never throws away a pointer. It collects pointers, and there's a number of different strategies for that. And then it used to be in Ruby and a lot of other languages that it would stop the entire world and go pointer by pointer and be like, do you have anything pointing to you? Do you have anything pointing to you? Do you have anything pointing to you? And this was slow. This is very slow. Not as slow as me. Computers are faster than that. But all the strategies, and there's some very good ones now, are some version of keep all the pointers and try and figure out how to get rid of them when they're dereferenced. So Ruby, I'm just going to go through these real quick. Get the idea. So the problem with that is overhead. I was going to show you some Ruby code, but it's not super important. There's a lot of something to add. So the other strategy, which is where we get into things like Rust, which you will finally be able to see at some point. ML, OCaml, anybody heard of that one? Some people have, yeah. Cyclone?
What?
Yeah. C++, kind of, right? Like they do some things. There's not many. Rust, definitely. All right. You can't. I'll just go through this.
Does Erlang fall into that category too? Yeah.
Or does it? I actually don't know the answer to that. Sorry. I don't know if it's really good about garbage collecting if it does, right? Because those processes are so small. So I'm not sure exactly how it deals with that. So don't worry about the code here. But what you need to know is that there is no null unless you explicitly say your code is unsafe, could crash. There's a way to say that. But instead we have optionals. And optionals just mean that there's a value or there's a value of none. Right? And you just match against it and do something special if there's none. So instead of just having a pointer that doesn't point to anything, you have a pointer that points to either something or a value that means nothing. Right? There's more to it than that. Writing to read-only memory. Box is a different kind of pointer. Can't do it. You can't free memory in Rust. The compiler inserts memory freeing and management stuff at the end of the scope. Right? So when your variable goes out of scope, there's no need to keep it. And there's a bunch of sort of semantics around how exactly all that works. But it's free. Accessing an array out of bounds. Well, there's just a little there. Sorry about this. It does a runtime check for array bounds, and that's what C++ does. It's really difficult to do a compile time check for array bounds. I think that they may be working towards something that can do that. But if you want to resize arrays or having a number of other semantics done. Shared memory concurrency. So the fact that you can't dereference memory, you can't actually pass out values without specific rules to multiple people. You can't have two processes that are right. This is all checked at runtime, and permanent is much more calm. So let's see where we at. All right. So go play with Rust. Rust gives you superpowers. I showed you some code. If it scared you, it's just some of the words are different, but there's nothing there's no manual memory management unless you want to do it, right? But it's there if you need it, and it's super fast. Let's see. And there's some resources. You can play with Rust online. They had a guy named Steve Klabnik from the Ruby community write all of their docs and a full book on how to how to use Rust with examples that run in the browser. They don't run in the browser, they hit a server. Let's see. Yehuda Katz talked about writing Ruby gems with Rust. And then I went through this whole roguelike tutorial that this guy has put on. It's a little outdated now, and Rust is updating relatively often, so you'll have to mess around with it, read some stuff online. But he gets most of the way through making a little game with some C library bindings in Rust. Let me just wrap up. So Rust is in. Let's see, do I have another slide? No.
So okay. Compile to C and then compile from there, or
no? It compiles to assembler. Yeah. Let me show you this Rust relation real quick. Function and so I'm just gonna let x equal 1, and then I'm gonna ln. Sorry, I know that watching people code is like so println is a macro, so you don't have to know what this is. Sorry, it needs semicolons. Right? Evaluate. Yeah, so I got 1 out. So that's great. But it compiles to it compiles to assembler, which runs on the LLVM. So that's exactly what I just did. You can see it's really straightforward. So that's the idea, is that it has that sort of power that assembler does, and that's what C really is. C is like a human readable version of assembler, and it doesn't care what you do with your pointer. It really doesn't care what you do with your types. If you turn off all the warning flags and stuff like that, it's just assembler that you can read better. Rust is kind of like that, but it gives you some high-level constructs. So Rust is in alpha. So Rust, as you get it now from online, it's feature complete. It won't change out from under you anymore. Some things might break, but all the features are there. I'm trying to think if there's anything else. I just found Rust super fun, so that's why I'm up here talking to you about it. I don't have a particular use for it, but I could if I write a Ruby gem. I'm just going to say that, and then hopefully convince my company to let me write stuff in Rust. But it's just as easy to get started. You can play with it, and I think that's about it. Are there any quick questions?
Maybe like 2 questions.
2 questions? Okay. Yeah.
Could you talk a little bit about the borrowing concept in Rust?
I could. And I think that's a pretty big conversation, which is why I stuck to one aspect. What he's talking about is how the compiler keeps track of what has a reference to something at any given time. So it helps with that. It's really important to that whole concurrency thing and making sure that memory is not freed by another function. Basically, Rust is the concept of things borrow a reference to your values, and that allows you to just know sort of where it is, and then give it back to the function that it was called from when it's done. It does that through something called lifetimes, but that's another discussion. It's all in that book. Any other really quick questions?
Yeah, I got a quick, they made a new browser, like the Firefox Developer Edition. Did they write that in Rust, or is that what part of it?
We're not there yet. So there is a browser layout engine called Servo that is written in Rust, but it's not passing all the various specs that you need to pass to be a HTTP or a web capable browser engine. But there is active development, and as it hits 1.0, it'll accelerate it. Cool. I think if you have any more questions for me, please come see me afterwards. I'll hang around for a while, and that's it for me.
Cool. So again, thanks a lot, Joe, for the talk on Rust. That was absolutely really cool. I don't think I was able to follow along with all the assembly stuff. I learned C at one point, but I kind of forgot it all, so it's pretty crazy. But next up, now we got Laurie. She's going to talk about pair programming. And I'm stalling while we wait for our AV setup to get fixed. It's gonna happen. It's gonna happen. Here we go. Oh, we're in the mirror thing. This is always one of the most. This is a lot more of a complicated process than people realize to get this set up.
So my computer's actually switched, so that's fine.
It's all right. Yeah. So we'll have a little bit of some like mingling afterwards, where you'll be able to gauge more questions on Rust. I don't mean to like run Joe into like lightning mode there at the end. That was really.
Oh, sorry. Yeah.
We will definitely have a moment there.
I was worried that I wouldn't have an
I thought it was really cool.
So I'll say what's going on and help me with this afterwards.
Yeah, Laurie has a very weird, if there's anyone that's really good with PowerPoint, she has a really odd thing happening with her machine, where you upgraded to, what's the latest version? Yosemite. Upgraded to Yosemite, and now every time she opens PowerPoint, every single PowerPoint presentation she has. Maybe it's just like Microsoft trying to be convenient for her. They're just trying to be helpful.
Laurie, if you open up the PowerPoint program first, you should be able to open up a single use its file open menu as opposed to going from the file to the PDX file.
Something happens with everyone.
Oh, a feature.
Uninstall button. So, but I mean, I do lots of PowerPoint, and trust me, this is not. This is not normal.
It's always just like the best time to fix, isn't it?
No, I mean, this is what's going on right here.
Have you tried turning it off and turning it back on?
I'll try running PowerPoint first.
No, I've done everything. I've shut my computer off. I've opened PowerPoint. I've closed every file.
You use Command W?
And it was even, it always is a shame because we even came up and plugged the computer in beforehand and did a spot check. And
Don't recover your work.
Yeah.
Check that box.
That's probably what it is.
Yes.
Oh, so a box came up and you clicked OK, and there was a checkbox in it that says, "Would you like to recover your work next time you open the So he is getting very, very confused because I think he thinks that you want to open all of your stuff back up.
Well, it happens in Microsoft Word and Excel.
Maybe that will cover your work.
Yeah, it's like anything.
Oh, you are crashing now.
Okay, so we're struggling. We're
Can you email
Instead of clicking on the PPTX, next time try opening it down in the application bar.
the driver navigator model?
So we have a pair programming demonstration happening for you this very moment.
It's never been a church.
Oh, try program. Well, you'll be taking a question or submit.
Yes. So you've probably heard this before, but why do programmers often get Halloween and Christmas confused?
Oct31 equals DEC 25.
That's correct. That was all I got.
There's at least 5 lines.
If you run it for down there, will it do the same thing?
I mean, this has never happened this many times.
Are you
Okay, so what you're going to do your members are either available with the slideshow period, he starts a presentation, and then it says, if you want to do consistent it doesn't map up what we're presenting. So now it's in the middle of the loop, trying to reopen it.
Just an idea, you could temporarily underline the files into it.
Alright, sorry. Anyway, I'm a professor at NC State, and I started doing research in Agile all the way back in 1998, and when I was a PhD student at University of Utah, and I did my PhD research on pair programming, which is an Agile practice. Now, I understand from Brandon that some of you know what pair programming is, some of you maybe do it, and some of you don't know anything about it. So let's, as a show of hands, who has never heard of pair programming before? Okay, not many. Okay, who has done it? Okay, lots of people. Who has done it often? Okay, so some. Okay, so that's good. And once I finally can show the slide. Thank you. If anyone knows how to fix it, awesome. All right, so, and what I specifically put pairing in software development, because you always hear the term pair programming, which makes you believe it's only for programming. But it's really for any aspect of the software development process. You can do pair design, you can like pair testing, pair anything. So we'll talk about what is it, and then research results, what's going on, some pair programming partner picking principles, and summarize. And what I was going to say is that if you've done it before, I would love for you to share your experiences, good, bad, and ugly, with everyone. Okay, so hopefully this one is unique speaking. So what is pair programming? Pair programming or pairing in software development is where two people are working at the same computer on the same task, kind of like what was going on here, right? We have one goal, we're all working on the one goal together. And the classic model says that there's one person that is the driver, and they have control of the keyboard or the mouse, or on a whiteboard, they have the marker, they're recording something. And then the other person is the navigator, and the navigator is watching the work of the driver and interjecting, and I'll show you a little video of them working together, and they're really working together. They're collaborating, they're talking. It's nothing like one person doing the work and the other person trying not to fall asleep. Okay, it's really a very collaborative experience. And then, the roles are not strict, so the keyboard is passed back and forth, as you'll see in the video, and it doesn't really have to be that, that you're in that kind of a mode. Here's a little comic. You drive, I'll criticize, and that's really not what it's meant to be. The role of the navigator is not just to tell the driver everything they're doing wrong. Okay, so now I have two videos I'll show you. One is good pair programming, and the next one is not so good. And this is why I didn't just give some of my PowerPoint slides, just so you can see this video. So I hope you really like it, since you had to pay for it.
Whenever they click export, we would pop up a file manager and let them pick where.
Alright.
Which I have no idea how to do.
That's a little bit more difficult. I was thinking for right now, what we could do is have them save the XML file under each of the projects.
That works for now.
So we can get the project information, like where it's actually the bus is to get the absolute path of it. So
Okay.
I can never remember the exact way to get it, so I have to play to what's Prince Albert Street allowed.
Okay. Okay.
Delete noise is not good fun.
Yep. Oh. Query for another time.
It's a super hard task that I'm not going to have this Tuesday.
Right.
Okay, so there's video. So, like, what kinds of things did you notice in that video about the way they worked?
One was more experienced than the other.
Yeah, so one's more experienced than the other. And that is typically the way it is. So usually when you are pairing, someone is in this particular class or whatever, they know more, and the other person is coming in. And so that is typical. Okay. What else?
Some of the feedback was more useful than others, as opposed to, yeah, okay, yeah.
Yeah. So sometimes it's just like affirmation or something other. What else? Yeah.
Seems like they've all had their guard down, and they weren't being defensive or anything.
Yeah, and that's good. It's good observation. That's really important that, you know, they're just very comfortable with each other, comfortable to get the feedback. Guard down is really what it said. Someone else was about to say something. Yeah.
They admitted what they didn't know.
Admitted what they didn't know. Yeah. And so I'm going to say that's something that comes with time. Really, the guard down and admitting what you don't know. That is something that will make people be hesitant to start their programming because they don't want other people to know that they don't know. And now you're having to show what you don't know, but it's like what you learn is what they don't know either. Like you might think everyone knows everything except for me, and then you find out that the other person, there's things that they don't know either. But that's something that comes with time. Other observations?
They're both paying attention.
Yeah, definitely. Both paying attention, yes. What else?
They were laughing and not cursing in the computer.
Laughing and not cursing, yes, that's good. Anything else? Yeah.
One of the things that I kind of expected to see, and maybe it just wasn't easy to show, is that when you're driving and explaining it to somebody else, that the process of explaining your code to somebody causes you to have a realization. I didn't see that, and that's something I didn't see that I kind of expected to see.
Yeah, and you are
From my past experience.
Yeah, that'll be on a slide. I'll explain that on a slide. So good straight man. But yeah, it's hard to capture that in a little video. But yeah, just the act of explaining what you're doing, you find your own mistakes. Yes, definitely something that goes on. Other observations? I mean, you know, you could see that they just kind of pass the keyboard back and forth.
Yeah, I mean, I guess one thing, it's not about the interaction between the individuals, but it's maybe an observation about the setup was that, I mean, the fact that they're using one small monitor and a single keyboard, I would say it might not be the most conducive environment to pair. Because having to do that thing where we pass the keyboard becomes a very, it's an obstacle that like, that navigator, to do the navigator driver switch, they did it very fluid. They did it very like fluidly. But it's difficult to do in a networking environment where things become intense. To actually like reach over and grab the computer, and it's very, it's a subtle gesture. Not really, it's not subtle at all. It's a very not subtle way of just taking over like what's going on. So it can be abrasive things that can happen.
Yeah.
They did it very well.
They did, and we have at NC State, we've had for a long time, a lab where it was a 6-foot table, which I think is about a good size, and then 2 displays, 2 keyboards, 2 mics, and you know, dual control of all of the I/O, and that does help out a lot.
So no switch from one keyboard mouse to the other. It's
Yeah. So you know, USB mouse, serial mouse, dual graphic card, 2 keyboards.
mirroring on the monitors, or?
Yeah, so yes, by default, mirroring on the monitors, but students sometimes didn't want that, and they would change it and have split things. And I've seen that in industry as well. Like a classic example is having the tests running on one screen and code development on another, and then there's one is writing the test cases more, one's writing the code more.
And that sort of devolved, but I guess they're still, it could devolve away from the concept of pair programming, right?
It could, but in this particular case, when I observed the testing on one screen and the code on another, they were doing test-driven development, and it was actually really interesting to watch because the tester would write the test case, and then the coder had to write the code to pass the test case. But they kidded with each other. So, the developer would write like return true, ha. And then the tester would have to write a better test case because return true wasn't really what they wanted. And then they would have to, they would go back and forth, really challenging each other to write a good test case and write good code.
And Laurie, we call that evil pairing. The idea is that your pair is supposed to implement it in a way that makes the test pass, but is subtly incorrect, or something that forces you kind of to do it. So when we do code retrieves, it's something we'll talk about is kind of that evil pairing.
Have you tested or played around with remote shared desktops, like you're with Daneware or something like that, where the two people may be in conversation with a microphone, with headsets, but they're not physically next to each other?
Yeah, so distributed pair programming essentially. Yeah, we'll talk about that in a little bit. Yeah, and that's more common now to do distributed.
Okay, questions about that, cultural questions, in case you've got, India and America, and how that works.
Yeah, we'll talk about that when we get in there. Any other observations from the video versus your experience for all the people that have done it? Yeah.
Yeah, I was kind of piggybacking off his. I've done a lot of pair programming. What I've noticed is when I switch from the driver to navigate, I never and that's never as smooth as that. Yeah. Usually it's a couple hours that I spend pair programming. And it's not I don't just grab the keyboard, but what I've noticed is when I'm in the navigator, I can tend to see more. I can see mistakes quick. Right. When I'm in the driver, I'll make up just some stupid syntax area, and the navigator catches it right away. Yeah. But it's one thing I didn't notice in the video was I saw that they were saying but it's really exhausting to do pair programming. Because if you're really trying to figure it out, it's almost like a mental marathon.
Yeah, no, I completely agree with that. And what I say is, for me anyway, I couldn't go more than 2 hours. Right. Because it's so intense. And when you work by yourself, when you're why is that happening? It's actually a little bit of a break, even though you're thinking hard. But when you're pairing, you're you're figuring it out, and after a while, to me, I would need a break. I know there's people who do it all day, every day. Anyone here ever done it all day, every day? Yeah. And is it exhausting?
Yeah, you work for 8 hours max and you stop, right? You really can't do it longer than that because it is exhausting. But I worked in an environment where I did it all day, every day for about, a year straight, and it was totally doable, but it took a good ramp-up period of about 2 months before I wasn't going home and falling asleep at it.
Yeah, there's so much.